Buffers. Buffers are solutions that resist pH change. They are really, really important in biological systems. Buffers work because they have significant amounts of both a weak acid and its conjugate base. So a conjugate base can neutralize acid. The acid can neutralize base. So if you add base to this buffer, the weak acid will neutralize it. If you add acid to the buffer, that conjugate base will neutralize it. It's got both of them. Human blood is highly buffered. Your pH is the pH of your blood is between 7.36 and 7.40. If your pH drops below 7, above 7.8, you die. You may have heard of diabetic ketoacidosis, very, very serious life-threatening condition where the blood becomes too acidic. There's a lot of talk about, different foods that make your body more or less acidic. They are not changing the pH of your blood. Your body regulates its pH very tightly. So let's look at a buffer system. Acetic acid and sodium acetate. So this is a conjugate acid-base pair. So we've got HC2H3O2, that's acetic acid, and we have acetate ion. So the difference between these two is a hydrogen ion. This is an acid. It's a weak acid because it's not one of the 6 strong acids. So in this buffer system, if you add base, the acid will neutralize it. If you add acid to this, the acetate is the conjugate base and will neutralize the base. And so it can maintain the pH pretty close. It resists changes. Now you can overwhelm the buffer, but a good buffer system can help keep the pH stable. Here's pictures. So here's our buffer system. We've got the acetic acid and we've got acetate. The sodium's just a spectator. When we add acid to the buffer solution, the acid reacts with the acetate and forms acetic acid. That neutralizes the added acid. When we add base, the base reacts with the acetic acid, neutralizing the base, forming acetate. And so the pH does not change. We need to be able to identify what is a buffer system or a buffer solution. What we're looking for is a weak acid and its conjugate base. So that's what we're looking for here. So we look at these two pairs. Are those conjugate acid bases? Do they differ by one hydrogen ion? No. They both have 2 hydrogen ions. Those aren't a conjugate acid base pair. They can't be a buffer. How about this one? Well, what is this really? That's sodium ions and fluoride ions. Is fluoride the conjugate base of HF? Does it differ by an H+? It does. So this is an acid, and that's its conjugate base. The sodium's along because you got to have something to balance the charge. So this is an acid-base pair. Is this a weak acid? Yeah, it's not on the list. So this is a buffer solution. Let's look at this one. HCl and NaCl. Well, let's separate that and look at the 2 ions. Chloride ion and HCl. Is that a conjugate acid-base pair? Yes, it is. So that's one thing. But is HCl a strong acid or a weak acid? That's a strong acid. Strong acids don't make buffer solutions. So that doesn't work. Here we've got sodium chloride and sodium hydroxide. Well, the sodiums are probably spectators, right? We've got chloride and we've got hydroxide. Are those a conjugate acid-base pair? Can you get from this one to that one by adding or subtracting a hydrogen ion? No. So that can't be a buffer either. So you're looking for a conjugate acid-base pair where the acid is a weak acid. If it's a strong acid, it's not going to work.